Everybody. Thank you for joining us for a special summer session of EI Live K-12. And my name is Cassie, and a big part of my job is to bring the science and the wonderful work that our staff and researchers do to different audiences, including educators and students. And so this is being brought to you by the Earth Institute at Columbia University. And for those of you who are joining us for the first time or have not heard of the Earth Institute before, our core mission is to foster a greater understanding of the science behind the climate crisis and sustainability and what we as global citizens can do. The Earth Institute is actually quite interdisciplinary. It's made up of experts that include earth scientists, economists, public health, and legal experts, as well as business and policy experts. The Earth Institute is made up of about 24 or so research centers that work across, with several hundred people who work across many different disciplines and departments at Columbia. So today we're going to have Laurel, Zaima, and Margie Turrin, who work at the Lamont-Doherty Earth Observatory, which is the largest research center that's part of the Earth Institute. They're going to continue their Hudson River series today, and they're going to specifically talk about the Hudson's habitat. We're going to be using the chat box for questions, and the chat box is going to be monitored as the speakers are presenting, so feel free to and they're also going to ask you questions, and so feel free to use that chat box to share questions and answer their questions as well. And then we'll open everything up for discussion and questions afterwards. So Margie and Laurel, you can take it away.
Thank you, Cassie. Welcome everyone, and for those of you returning for day 2 of our Hudson workshop, welcome back. Again, if you were joining us yesterday, we're going to start with a Mentimeter. For those of you who are new, I've also put the link in the chat a couple times. I just did it again. So click on that link, and all we want you to do is write the first 3 words that come to your mind when you think of Hudson habitats. Don't go digging, just the first 3 words. And we have 5 people who've done it already. It comes into this amazing word cloud, and so we can share it once everyone's finished. But while we're waiting, we can introduce ourselves.
We can, if I can get us moving forward. So yes, hello everyone. Welcome, and we're excited to spend some time with you. My name is Margie Turrin. I'm Director of Educational Field Programs at Lamont. We have a field station that's on the Hudson River that we are suffering from withdrawals because we haven't been able to spend time there this summer, but hope to be back soon and really spend more time actually studying, sampling, and educating around the Hudson.
Yes, and my name is Laurel Zaima. I work at Lamont with Margie, Nina, and Cassie. I'm the Education and Outreach Coordinator, and today we're focusing on Hudson habitats. Let me just check the Mentimeter. All right, we have 11 people, so I can share my screen and show you what is popping out. So the way that a word cloud works, in case you've never used it before, the bigger the word, the more people had written that word as one of the 3 things that come to mind when they think of Hudson habitats. So diverse is blown up really big, which is great. Estuary, which is also wonderful, that we're already knowing that the Hudson River is an estuary, the lower portion. We have some other things like rich, mud bottom, essential, turbid, a day in a life. So we have some participants of the program that we help run with the DEC every October. Marshes, varied, improving, comeback. This is great. So this is just a great thing to start your students kind of brainstorming, getting their little wheels turning about the subject, and then you can always do one at the end as a pre-post so they can see how much they've gained and learned. So thank you guys for doing that. So we are also going to do a quick poll. because we introduced ourselves. We want to know who you all are. So feel free to fill this out. We just wanted to know your role.
All right. So we have 13 of 16 participants. I think everyone did the, 14 is coming in. We're almost there. Anyone else? I'll just do like 5 more seconds. All right, so we can see that most of the people today are formal educators. Can everyone see the results of the poll?
Mm-hmm. Yeah.
Wow, formal educators, informal subject specialists, and 2 students. So welcome everyone, we're so happy to have you all. This just helps us to think about and formulate how we can direct and help you guys use this lesson best in your classroom. So first, what is a habitat? So of course, it's a natural home for an organism, and for any place to be a successful habitat, it has to have the things necessary for an organism to live. So that includes food, water, and shelter. Of course, humans have a role in the natural world. So one thing we're going to be kind of talking about and focusing on today is what role do humans have in habitat protection, and what role have we played in habitat destruction? So those 2, protection and destruction, human impacts. Okay, and so this image on the right-hand side, we're looking at the Hudson River watershed. So it's hugely expansive across New York. And one unique thing, not only about the Hudson River watershed, but the Hudson River in general, that you guys are already familiar with from the Mentimeter, is that it is an estuary, which makes it extremely unique and very diverse. So a couple points about this amazing ecosystem. It's connected to the Atlantic Ocean, which then makes it an estuary with the tides. We have freshwater origin coming from a variety of tributaries from this watershed feeding into the Hudson. So our freshwater isn't just from one source. We have these amazing mountain and forest habitats from the Adirondacks, Catskills, and Hudson Highlands. Marshes are a critical piece of the Hudson River. And we have saltwater, brackish, and freshwater marshes. An expansive mudflat habitat, backwater channels. These are all habitats that are used widely among a lot of different organisms in the Hudson. And of course, submerged plant beds. These are some key things that we're going to be talking about today, but each one of these critical habitats are used by a wide range of species. And so throughout this presentation, we are going to be looking at each one of these habitats and habitat challenges as a story or a case study, if your students are already familiar with case studies. These are some key points that are going to kind of thread its way throughout the entire presentation, but every part of the river has a habitat, and each one of these habitats supports this huge range of species. Humans, of course, we are not separated from the natural world, so we inevitably have an impact on these habitats, and especially in this very urbanized area, we have altered many of the habitats, if not all of them, on the Hudson. However, New York State and New Jersey State both have designated areas of critical habitats that are intended to help protect these areas for species that are using them and living in them. So that's extremely important. And of course, we've developed a lot of the area along the Hudson, but even in the most urban areas and altered areas, this is still a habitat that's being used by a lot of species. So I think that's something that your students might not realize. All right, so first we want to know, what are some habitat challenges for fish that you already are familiar with? So there's this great feature on Zoom called the whiteboard feature. I'm going to pop that up. You guys feel free to shout out at me or use the chat telling me some of the challenges that you're already familiar with, and I can kind of capture that data on this whiteboard feature. So Hudson habitat challenges.
So Jody says pollution, and you guys feel free to turn on your mics and talk. You don't have to stay silent. We're happy to have this be interactive. We see PCBs, many cities. Okay, wait. These are coming in fast and furious.
Great.
Oxygen. Invasive species.
So,
Invasive species, yep. We have thermal pollution. Sewage.
I'm assuming oxygen meant like low oxygen challenges.
Yes.
Okay.
So sewage. Concrete embankments.
How about
So
storms?
concrete,
Like hardscaping?
concrete, yeah, hardscaping. Storms, is that what you said, Mary?
Yeah. Yes.
Yep, storms is great. We've got runoff, which would go with storms, but can be separate. We've got development, which I think might go with cities, but we'll keep it separate. We've got river traffic. I'm going backwards now because I know I missed some. Things were coming in before I could get to them. Oyster beds had huge die-offs. So that's a challenge in terms of keeping the oysters alive. And did I miss any, guys? That's a pretty good list.
This is great. I'm going to save this because this is so...
And we also have noise from boating. So we have noise pollution.
Noise pollution.
And climate change.
Ah, great. Can't forget that one. Okay, now I'm going to save it.
Wait, no, we still have one more. Acid rain. Clearly, we have a lot of challenges, folks.
just a few. Okay, thank you all for doing that. I'm going to let Margie reshare the PowerPoint. Another great way to gain information from your students or from the students that are joining us today and what you already know about habitat challenges. Perfect. Thank you.
So that was great. I wish we had time to talk about all of them, but we could be here for a long time. As we know, there are many, many stories about what's happened in the Hudson River, and each one of them I think is a great way of helping students kind of dig into a topic because they have a little bit of kind of connectivity to them. You know, they really resonate. So that phenomenon piece that is really important in teaching today really comes alive in some of these stories. We're going to talk about a few of these things. You mentioned way more than we're going to be able to cover, but happy to answer questions or chit chat on any of them at any time. We're going to start with talking about habitat and spawning ground destruction. So dredging of the shipping channels it was done for humans so that we could bring in traffic, etc., but it's had its own impacts. Filling in coastline and backwater channels. I know that Jean had asked me about what is a backwater channel. We're gonna dig into that in a little bit, but ultimately the river was set up, originally it was created with these kind of islands in the upper part of the Hudson River, and behind them were these kind of quiet channels that were really great for young of the year fish and spawning areas. Those were destroyed basically by human activity. So with a combination of dredging and dredge spoils being relocated, we filled in a lot of that to create additional land space. So those backwater channels are a thing of the past, and we'll look at some old images to see that. We filled in wetlands and marshes, again, in many instances for health reasons, but that's had its own impact. You did mention invasive species. We'll be talking about that. We'll be talking about power plants and how this history of once through cooling, which no longer is legal, but there were some trade-offs and things that happened that allow some of that to continue to exist. And then how those still, even with the twice through cooling, are releasing warm water into the Hudson, which is having an impact on the fish populations. Again, anything that pulls water out of the Hudson in large volumes will have an impact on very young of the year fish. whether it's impinging it, so sucking these young of the year fish into a screen, or in training it by pulling fish eggs, et cetera, right into the water intake, has an impact. Climate change is increasingly something that is talked about, and what are the impacts of this increasing temperature? So we're seeing the river warming, and certainly our fish have specific temperature ranges that they're successful in. And again, that kind of hits on to the next one, which is the lowering of dissolved oxygen. So warmer water holds less oxygen. And these CSO events, so combined sewage overflow events from runoff, from storms that hit in multiple places on the river, most notably in the Albany area and in New York City area, has a big impact on oxygen. And the image on the bottom of this page, by the way, is taken by a friend of mine, John Young, who does amazing photography on the Hudson. This is of the old bowline plant, which is now Gen 1 plant that's down in Haverstraw area on the Hudson. Okay, so we're gonna dig in. Okay, so we're gonna start with habitats and the spawning ground impacts through dredging, deepening, and filling. So how we've really recreated space. This is an image of dredging down in the harbor area, actually. So we have dredged the entire extent of the Hudson River. It was critical for human use in the way that we were using the river. So we were trying to move these large vessels all the way up to Albany. We were, more recently, we've been moving these large container ships into the New Jersey side of the river, into that port area. And so dredging has been a part and parcel of our life. And because of that, we've completely destroyed a lot of the benthic habitat, which is the habitat that's on the bottom of the river. And created these big fill holes, actually, which has its own impact, because I guess probably most of us are familiar. If you dig a hole, that sediment wants to refill that hole. That's the first place it's going to move back into. And so a lot of the contaminants that were actually added into the river through the course of its history, and up to and including PCBs, have kind of recollected in those deep pocketed areas that we have dredged in the Hudson River. So that's had its own impact. The filling of these backwater channels has really destroyed a lot of the area that the fish use to spawn. So we're seeing that we have narrowed the space that's available for spawning, and we are known as a spawning river. So this particular combination of runoff from our freshwater tributaries that brings lots of nutrients in, and the connection to the Atlantic Ocean, which brings in those migratory fish, is really an attractive kind of partnership for spawning of young of the year fish. The nutrients that are running down are, and the leaf litter, et cetera, has a lot of macroinvertebrates in it. It's a lot of food for these young of the year fish. And so we bring in these migratory fish, but we have reduced the space where they can really continue to spawn, which is indeed a challenge. Again, we filled in a lot of the marshes through much of the Hudson history, and I'll show you an image that goes back to the 1800s. The Hudson was filled with marshes. All the way down into the New York City harbor area, we had marshes all along because it wasn't anywhere near as deep as it is now. And in fact, there are many accounts of when the early arrivers into the Hudson from the European group entered into the Hudson. When they got up to the upper Hudson, the entire upper third was actually they had to hop out of their ships and walk and pull the ships behind them. So they had to portage that area because they couldn't actually navigate it by boat. So we have completely changed that. I mean, no one would ever even think at this point that that was the situation. And then we even created these kind of isolated embayments by installing railroads. I noticed that nobody mentioned railroads, but indeed railroads have completely altered a lot of our edges of the river. So many of you might be familiar with this particular image on the left, which is from the Manhattan Project. It's looking back. It's a recreation of the habitats that might have been. This was done by Eric Sanderson back during the quadricentennial and the bicentennial. And was done through a lot of painstaking looking back at historic records to try and put together what was it like when the European settlers originally arrived in this area. And so juxtaposed beside it, we see modern Manhattan. And I am going to challenge you to see, what can you see that might be the same? What are the pieces that you can pull out of this that look as if perhaps they haven't been completely altered? And I'll give you a minute to kind of dig in, and then you can either pop things in the chat or you can talk it out loud. Anybody see something that is much the same as it was? It's hard. Yes, okay, so thank you. The Hudson and East Rivers, they're still there. They might look a little bit different. Even the Harlan River, you can pull out the Harlem. The basic shape, although it has been expanded, absolutely, Marissa. So we did a lot of filling right on the waterfronts. We built places where we could bring our ships in. So we have kind of widened a lot of, if you look at the old street names, you can recognize that Water Street, Front Street, a lot of these were actually where the water was or where these areas were. And now it's all very, very different than that. You won't see that any longer. You can see, so this area here you see is two different islands. We've combined that now into Randall's Island. So Ward's Island and Randall's were two different islands. They've now been merged. This is something that we do a lot of. We tend to, Governor's Island grew. Yes, in fact, it looks much bigger than it used to. It's very small there and much bigger here. Roosevelt Island looks a little bit the same in terms of size, but very different in terms of being, built all over. And of course, this swath of green, the trees and the habitat, completely different. So you don't see any of that anymore, with the exception of, you can pick out Inwood Park way up here where the Harlem goes off of the Hudson, at the Spite and Dival. So you can see little remnants of that, but we have transformed this particular part of, and not just this particular part, but the entire part of the river. So we'll take another kind of deep dive back in time, and we're going to look at this area in the upper Hudson near Castleton, and we're going to look at a historic map to look at where we would have found islands. So in this particular map, the red area is the historic shoreline. So you can see in this particular map, we've narrowed the Hudson. We've narrowed and deepened that section for navigation purposes. And as we deepened it, we took the fill and we threw it in behind. So the orange would have been our historic islands. So you can see we used to have islands here. No longer. This has all been filled in now. So this is a contiguous bit of land at this point. And the blue area is now hardened edges. So like diked edges, rather than being an area where the water can kind of flow in and just be absorbed and move freely. So it's created a problem in terms of climate as well, in terms of the impact of water. If you have a storm, you really don't have the ability for it to dissipate that energy in a natural way. It's going to be hitting up against the edges. And again, as I mentioned, these backwater channels were an incredibly productive area for young of the year fish, for spawning. All of that habitat has been lost at this point in this particular area. There are a couple of places where we still have what we call a backwater channel, but large changes. And then additionally, I popped a little picture down here of the railroad, and you can see how the railroad, of course, when they were putting the railroad in, it was much quicker to go straight, much cheaper. So they built up these kind of reinforcements under the rail line itself and kept it going straight, which of course cut off all of these normal flow, the natural flow, and these little cove areas. So it completely changed how water moved in the system. So this is just a graph that can kind of talk to us a little bit about what the heck we did in terms of volume. So prehistoric, So pre-1907, this is the deep water area. So there were about, which we're defining as greater than 6 feet, which is actually not all that deep, to be very honest, but it's how the distinction is made for the shallow water areas where the young of the year fish really thrive. So you have greater than 6 feet, about 4,000 acres. And now we have almost an additional 1,000 acres. This is where the big difference is. You look at this large area of shallow water, like almost 5,000 acres of shallow water. That's down to less than 2,000 acres. And you see that it doesn't get picked up in this deeper area because that's all been filled. So we just plain old lost that water area entirely. And then we have 2,600 pre-1907 acres of intertidal marsh, and that's been cut in about half. So you can see that we completely changed this area. So a huge impact on our fish spawning areas. Okay, so now we're going to move on to the role of the marshes. So we're right now looking over the Bear Mountain Bridge, for those of you who might not be familiar with this area of the river. This is the Manitou Marsh. It's a marsh that is well known for stripers, so little young of the year striped bass love to move into this area, and they find some protection in there. One of the great features of a marsh. And then you have these wonderful Hudson highlands behind it. So it's a beautiful, beautiful area. So the marshes have a variety of uses. A lot of them are benefits for humans. We're looking right now at the benefits for habitat. So we have 3 different types on the Hudson River itself. We have saltwater, brackish, and freshwater. If you start down in Staten Island area where Mary is, we've got these wonderful expanses of saltwater marsh. If you move up to our area of the river where Laurel and I work, which is the Piermont area, we have the largest brackish marsh in the Hudson River. And a little further up, Iona is also considered a brackish marsh. And then above that, the marshes tend to be considered freshwater. And marshes are an amazing web of food for a variety of species, everything from fish to macroinvertebrates, birds really thrive in these areas, small mammals. So really a great range of biodiversity, and a real benefit to the ecological community when they exist. They're a great refuge for fish and invertebrates. So we do some monitoring in Piermont Marsh of crab species. We also do a lot of other ecological species with students during the summer. It's and this is not a pristine marsh, by the way. This marsh has been overtaken by an invasive species called Phragmites. But even with Phragmites taking over a lot of the function in this marsh, it's still a very rich ecological habitat. Lots of species are found there. And again, the plants that are there are often a habitat and a home for things like muskrats, in some areas beavers, you know, a variety of different creatures. So they really take advantage of it. And we definitely have muskrats in our part of the world. Marshes are also, of course, a huge benefit to humans in terms of sea level rise. So as the sea level goes up around the world, it's going to be affecting us on the Hudson because we're intimately connected to the Hudson River. And in New York State, we're going up just under 3 millimeters a year. And I was just at a presentation that they did on Piermont Marsh, and the projection is that by 2100, sea level will have taken over Piermont Marsh. So we will potentially lose this marsh. So one of the challenges with the marshes on the river is they need a place to retreat. So if sea level rises, you have all the sediments that actually came down to create the marsh. We're looking at what happens to that marsh. Does it get buried, or does it have the ability to retreat back into the edges? At Piermont, there is no ability to move backwards because we have Tallman Mountain. We have the Palisades Sills that runs right behind here. I'm actually up in the Palisades taking this picture looking down. So there isn't the ability for us to actually migrate. And that's the case with a variety of our different marshes on the river. And it's something that's being actively studied. I wanted to just go back in time. So there was a wonderful panorama that was done by Wade and Kroom in 1847, and it's in the historic library, and you can find some versions of it online. But it's a hand-drawn, hand-painted trip down both sides of the Hudson River. It's just incredible. And it folds out in pieces. And this is just looking at the Croton area, but it gives us a look at what it was like back in that period of time. What was the environment? And what we see is that there were marshes all over the lower Hudson and all over the upper Hudson. So they really dominated the fringes of the Hudson River. And unfortunately, a lot of them were filled for what was called health reasons. So in that time, there wasn't an understanding of the ecological value of a marsh and any of the ecosystem services that it provided. And so they worried about mosquitoes or diseases that might come out of these kind of mucky, wet areas, and decided to fill them in, build on them, remove them. And unfortunately, that's what happened to a lot of the lower Hudson. So just a quick kind of look at Piermont Marsh, just to give you an idea of what are some of the benefits of these marshes. This is a 2007 study that was done in Piermont Marsh and just looks at the variety of different habitats. You'll see that orange dominates, and of course that's that invasive Phragmites australis, but there are still lots of other different types of plants in there. There's typha, which is cattail. There is some blanking on what I want to say, Spartina, two different types of Spartina. So Spartina Spartina alterniflora, which is the taller version, and then the natans, which is the lower version. So a variety of different habitats, each of them providing some ecosystem service for some species that's in the marsh. And then I popped up a picture of this beautiful diamondback terrapin because this was netted by mistake. We were doing a seine run, and this actually happened to come up in the net at Piermont. But this is their habitat. So they are specific to a brackish marsh environment. They're beautiful species, and one that we're really happy to have in Piermont. So having this really great habitat right next door is a really cool thing. So I want to just step to, as long as we're talking about marshes, so there's a very tight relationship between marshes and the railroads. Some places had marshes before the railroad was installed, and those marshes expanded because of the railroads. Some of them, the marsh areas were altered or eroded because of the installation of the railroad. But I wanted to mention that in the Hudson River, we have 4 sites that are called Hudson River National Estuarine Research Reserve sites. Those are NOAA designated sites at the national level, and they're run in partnership at the state level. So ours is run in partnership with NOAA and the DEC. These are 3 of them. The 4th you just looked at, the 4th is Piermont. Piermont does not have a railroad. That's part of its makeup, but the other 3 do. So again, marshes ended up getting impacted by the creation of the railroads. So you can see here that orange is the railroad, so you can see a massive amount of railroad here. Pretty nice slice of railroad here. So this is Iona Island. This is Tivoli Bays, which is up further up. So Iona is just upriver from us, sorry, in the Haverstraw Bay area, so close to Piermont. Tivoli Bays is much further up in the freshwater part of the river, and you can see the most of Tivoli Bays is kind of captured and held behind a railroad. And then Stockport Flats, which is the furthest north of our marshes, there's just a little bit that's captivated and held behind the railroad. But again, the railroads have had a big impact on what we see as our landscape.
All right. Thank you, Margie. So another habitat challenge, something that you guys had already recognized on the whiteboard activity, invasive species. So we're only going to touch on 2 invasives today, pictured in this image. I don't know if you guys are familiar with them, but these are 2 of the biggest habitat disruptors for sure. As most invasives, they are just very successful when coming into this new territory. So we're going to start at looking at water chestnuts, also known as Trappa natans. So this is what water chestnut looks like. You guys can see it has broad leaves that sit on the top of the surface. They have these bladders filled with air that help them to rise to the surface so they can float. And these broad leaves kind of take up the sun, any sunlight that would have normally reached down to the bottom of the river, which would support life or sunlight for other submerged aquatic vegetation, some of the native species. So this is our water chestnut here. The seed before is also referred to as devil's horn. So that's one of their reproductive strategies, their seeds. So the history of water chestnuts, they're actually native to Europe, Asia, and Africa. So we believe that it was introduced way back in the late 1800s through the Mohawk drainage basin, which Margie can kind of like point out the Mohawk area. Perfect, thank you. And so we think that it was intentionally introduced as waterfowl food or as a feature in water gardens, and it had escaped from these water gardens. But this map that we're looking at is the density observations between quite a long range of 1994 to 2014. The redder the color, the higher the density of these water chestnuts. So they have really made its way throughout the entire Hudson and neighboring tributaries, and they've are pretty well established in this freshwater section of the Hudson. So they have stated by early 1900s, water chestnuts were pretty well established. And so like many invasives, they don't have a lot of predators because they're new to this area. They have great reproductive strategies, which help them to just disperse throughout an area. And these water chestnuts in particular, because of their broad leaves and the way that they have these leaves floating at the surface, they outcompete other native submerged aquatic vegetation for sunlight. So they're just great competitors. So these water chestnuts aren't entirely bad, but the negatives definitely outweigh the positives. So a few positives that are noteworthy. It does create a feeding area, although the water chestnuts are so dense that it's quite a challenging environment for species to live in. Because they are a rooted plant, they can help prevent erosion, and they do help with slight wave attenuation because they can absorb some of that wave energy, but not to a significant amount. Like if a large storm was coming in, they would be ripping out all of these water chestnuts from this area. So the negatives, because they have their photosynthesizing leaves at the surface, they actually don't produce dissolved oxygen in these areas. They actually decrease the dissolved oxygen. So they are actually photosynthesizing, producing oxygen right into the air. But because these trappa beds are so dense, they actually decrease dissolved oxygen because they don't let a lot of wave action in. The temperatures are warmer in these beds because it doesn't allow for flow. It's just heating up this area, which warmer water holds less oxygen. So these trappa beds are known to have pretty low oxygen levels, making it very hard for species to live, unless they're very hardy. So there's little habitat value because of that. And although they were introduced as a food for waterfowl, they actually have very little nutritional value. So not a great benefit in terms of food for these birds. And they actually, because they're so dense, it can impede commercial and recreational activities. So I know, Margie and I have spent time canoeing in an area where there's this huge trappa bed, and you can only go a few feet in before you have to kind of backpedal your way out because they're so dense, you just cannot make your way through it. So it really can impede boat traffic. And because they are so successful with these reproductive strategies, they create this monoculture. So in this image, I just wanted to point out this seed. It's a very hard seed. So animals have a hard time even trying to consume it. And these spikes actually are a way to spread themselves. If they get entangled in any bird or animal, then they kind of hitch a ride and can get transported to a new area. So they are just very successful in terms of their reproductive strategies. And the reason why we're so concerned about these trappa beds taking over is because this monoculture outcompetes the native submerged aquatic vegetation, also known as SAVs, which are native species that we're trying to kind of protect. Our Vallisneria, also known as water celery. So the water celery is this native species. They actually are submerged in the water. So when they photosynthesize, they're producing dissolved oxygen, making a nice healthy environment. It's a very important habitat for a lot of different species. It's also a food source for different species as well. So Vallisneria is this native plant that creates this rich habitat. However, when trappa is coming to invade, they outcompete them. So if we're looking at this graph in 2007, TN stands for Trappa natans, so that's our water chestnut. SAV is the submerged aquatic vegetation, referring to the water celery or Vallisneria. So in 2007, we have the trappa coming in, taking over almost 2,000 acres. But SAVs were very well established in the Hudson as this native SAV. So over 3,000 acres of Vallisneria. However, just in 7 years, you can see not only did trappa take over in terms of the acreage, now they are over 2,000 acres, but you can see that this dramatic decline in the native SAV down to just over 1,000 acres. So looking at the percentage change, maybe trappa increased a little bit, 11%, but SAVs decreased by 64%. So trappa, they're really stable in the Hudson. They can weather some storms. SAV maybe are a little bit more sensitive. So we can see from 2007, the Vallisneria took over 6% of the river bottom, but now 2014, only 2%. And I know that's relatively, it's a little bit older data, so it'd be interesting to see what the percentages are now that we're in 2020. Is it possible to control or eliminate the chestnut population or the trappa population? Yes, so there are some there's a couple different strategies you can. I know some of our colleagues, they have a trappa bed outside where they work, and so they manually remove these water chestnuts from the water, but it's extremely labor intensive, extremely time intensive. You also have to get them from the root, so that's challenging as well. There's a mechanical way to kind of rip them out of the ground, but that can be super destructive to the benthic habitat as well, expensive, and doesn't necessarily guarantee success because the next season they could just come back. So it's really challenging with any invasive that's really established itself into a new environment. It's really challenging on ways to completely eradicate it from that said environment, but there are definitely ways that you can help to control. And so they're kind of controlling with that hand removal, but they're also trying to help stabilize the Vallisneria populations by planting more of that SAV. So kind of helping in ways that we can. And invasive species number 2, zebra mussels. So zebra mussels, a freshwater species, they were actually introduced from the Caspian Sea from the ballasts of ships. So when the ships are coming into new areas, releasing that ballast water, these guys were kind of like a stowaway. So this is a type of bivalve or like a mollusk. They have a hard shell, but they have a soft inner body. And so they're very similar to clams, oysters, mussels. You can tell your students, and you can see that similarity in this picture here. And they are extremely successful at reproduction as well, and they really like to settle on any hard surface. They are amazing at just settling on anything hard here. I have a couple questions relating back to the water chestnuts, so I'll just touch on those. Can it be used to feed farm animals? I haven't, maybe Margie knows, but I haven't heard of them as animal feed, but I know that someone was telling me that water chestnuts can be used in, I don't know, maybe it was a different type of water chestnut. We were having a debate with some teachers, and I think someone said that they can be used in some dishes, but.
So I did just put an answer to that. It just that, yes, I mean, we could try and do some of that, but ultimately I think the biggest challenge we have is getting them out of the water in the first place. So just that massive removal. And I think that the preferred method would be to actually get rid of seeds. And in most instances with invasive plants, the idea is to get them at a hot enough temperature that you actually burn them so that they can't regrow. So it's one of those difficult things. The seed pod on these, as I think Laurel mentioned, is so hardy. These come back. If the seed is down in the bottom of the river, we can expect to see it in 15, 20, maybe even longer than that years. That I think is really the challenge.
And Jody asked, do students raise wild celery in the classroom to help restoration of the beds? Yes, so that's a program done by some of our colleagues, the New York State DEC Hudson River Estuary Program. Students, they help to grow this Valsinaria in a tank in their classroom, and then I believe they help plant them after. So do they help in the planting process?
It depends on whether they can coordinate it or not. It's not, especially for younger students, it's not all that easy, but they have actually had the students come out and watch as the staff has helped to put them in the ground. The success rate on some of those is a bit mixed, so they're challenging to try and reinstall. One of the things about these particular plants that we learned after Irene and Floyd, the big events where we had a lot of additional sediment end up in the river, was that they have a tuber system that's actually connected underneath the sediments that really wasn't that well understood. It got buried under all the sediment, and that put really stifled the growth of the plant. But the reason for that wonderful tuber system is that the plants then don't get quickly ripped out by wave action or storm action in the river. So it's hard to get them to reestablish. But it's a great project, and the students really love it. They measure it as it grows and stuff. So we could put you in touch with Rebecca. I'm sure they'll be doing that again.
Mm-hmm.
Could I ask a question?
Yes.
Yeah.
Hi, this is John Ashon. I teach at High Meadow. What is the best grade level or the recommended grade level? You said it was better for older students. What do you?
No, not necessarily. What I meant to say, or what I was trying to say, is that the actual planting works better with the older students because it's not something that's that easily done by younger students in the river. But I know that Rebecca started actually with young students and having them measure and track it. She's tried it with older students. I think she's, i.e. middle school and high school, and has tried to add some additional measuring components onto it. So it's not just watching the biology, but maybe taking some measurements, of other factors, pH in the soil, et cetera. But Rebecca, so that's the person who's really been coordinating all this. So that's the person to check with.
Great, thank you guys. So zebra mussels. Margie, you can click to the next slide.
Oh, sorry.
Okay, so we kind of talked about zebra mussels as an organism. A little bit more on why they are such successful invaders. They live 2 to 5 years, but they have great reproductive strategies in terms of spawning. So each year, females release up to 1 million eggs, and males produce 200 million sperms. So great reproductive strategies, and it allowed them to just invade these freshwater areas. Their impact can be seen. You can look at this graph here. So we're looking at the impact of zebra mussels on each one of these different parameters on the x-axis here. And the y-axis is change associated with zebra mussel invasion. So if we're looking farther towards the left-hand side of this graph, we're looking at a decrease in phytoplankton, zooplankton, native bivalves. So they are filter feeders. They're consuming a lot of these plankton and then outcompeting a lot of these bivalves. They're also, if we're looking at decreases dissolved oxygen, and some of the things that they're increasing, transparency. So if you're thinking about a filter feeder, they're actually consuming a lot of the things that would be making our Hudson turbid. And our Hudson is a naturally turbid system, but things like plankton and phytoplankton, that is a contributor to the turbidity of the Hudson. When we have a lot of zebra mussels, they're filtering all this water and they're increasing the clarity, which some people can look at clean water and think that's healthy water, but not for the Hudson. The Hudson's naturally a turbid system, so that could actually be a real challenge for us as well. Perfect. So this is also just touching on that. And remember, we were talking about that these zebra mussels are great at attaching to any hard surface. So this is a picture of zebra mussels that have attached to this pearly mussel, this native pearly mussel. So they can just really attach and grow on these different hard substrates and other animals. So in talking about their impact with water clarity and turbidity of the Hudson, this graph we're looking at chlorophyll as a proxy for phytoplankton. So the first bit is looking at the average for December 1973 to May 1992, before the zebra mussels have invaded. We have this level of chlorophyll, which is telling us that there's productivity in the phytoplankton in this area at Kingston. However, looking at this next bit of the graph, from June 1992 to June 2013, when the zebra mussels have started to invade Kingston, we see that huge drop in chlorophyll. So you can see that this invader has an impact on this ecosystem in a variety of ways. And so that's a real challenge with invasive species, is that they're changing the ecosystem, they're changing the habitat for these natives that can't compete with them.
Okay, thank you. So we're gonna move on to our third area, which is our insatiable appetite for energy, of which unfortunately I think all of us play a role. And this is probably a story that's familiar to many of you. This is a story of Storm King Mountain and the whole desire by an energy company to actually alter the face of Storm King and put in these water turbines to pump water up to the top of Storm King and put it back in Black Rock Forest, and then provide that water in terms of generating energy in an off when that was needed. So Storm King is absolutely iconic. It's a place that a lot of artists have painted about, and travelers have written about. It really dominates the Hudson Highlands area. It's an incredibly beautiful rock mountain surface. And this was part of what caused this to become such a hotly contested topic, because it was really iconic, and a lot of people that lived in this area were not willing to just let this change go forward. So this is just a graphic of what the idea was, but they would at nighttime, when there was not a huge need for energy. So this was an energy loss, by the way, just so that everybody understands. It took more energy for them to actually pull water from the Hudson and pop it up and push it back here and hold on to it in Black Rock Forest than they were going to get by releasing that energy and driving electricity. But the deal was they needed that electricity during the day, and they could pump this up at night when they didn't have that need. So to them, they could sell it for a profit, and that was really their goal. And this was, of course, Con Edison. So this was their schematic. This particular image was their undoing. This was published in the local paper, and it really showed what the people that were in the area of Storm King would be seen and faced with. And that became an issue for the aesthetic beauty of the area. But then they also entrained the help of the local fishermen. And so there was a group called the Hudson River Fishermen's Association, which has been active for many years and has actually been leaders on a whole range of environmental issues on the Hudson, who helped with stepping in with their understanding and knowledge of the river. So one of the things that they were aware of was that this was a spawning area for striped bass. There were a lot of young of the year striped bass in this area. And they also were aware of the fact that this was a tidal river. And so the people that were generating this plant didn't have that, that same sense of knowledge. They were trying to do counts of striped bass and were unaware of what those numbers would actually mean. The fishermen were aware that they were actually double counting the fish, but they weren't going to let on that because they were very interested in protecting the spawning area. So there was a lot of scientific research that went into it. There was a lot of political capital that went into it. There were groups that formed around it. This was the origin of the Scenic Hudson group that manages land along the Hudson River and has been instrumental in protecting a lot of the habitat that we now see return to use. So Scenic Hudson is noteworthy for purchasing old brownfields, old sites that have had a prior rather degraded use and trying to turn them into parks and bring them back into a positive ecological benefit for the river, which is incredible and a really wonderful legacy for them. So again, this particular image was what caused a huge battle. It went on, it was a protracted battle that went on for years, actually. And in the end, there was an agreement that was signed that protected Storm King. It wasn't as in any situation where there's a long fought battle and there's a lot of money involved and a lot of resources that are pulled into play. It normally isn't a one-way decision. And in this particular situation, there was a decision that was brokered that's had a long-term impact on the Hudson, and one that has been second-guessed many times since then. And I know it's always easy to second guess these decisions and think back about why was that ever agreed to. But at the time, again, remembering this was years in terms of, so you can see 1963 to 1980 was almost 2 decades of legal battles and trying to generate resources in the community, financial, to go against these very large corporate attorneys and corporate groups. So the decision ultimately was, this was after the time of the Clean Water Act, and there was a requirement that any power plant installed twice through cooling. So instead of pulling water from the river once, they were required to recycle that water, which would reduce thermal pollution and it would reduce impact on impingement and entrainment, as I mentioned earlier. So pulling little fish up against the wires that are on the fronts of these suction lines and pulling in the fish eggs themselves. So there was an agreement that Indian Point would be allowed to push that off and not have to comply with that twice through cooling. There's a lot of discussion about whether that was a permanent agreement or whether it was just an installment where they had a little bit of additional time. But there are huge fish kills that go on in terms of young of the year fish and eggs at Indian Point. And so it has been a long fought battle. As you probably are aware, Indian Point has already started to close now, so it won't be doing this down the road. But it's been a long, protracted discussion. So there's a picture of Indian Point. And again, just to kind of bring up this whole idea of thermal pollution. So this is an image that shows thermal pollution from both Indian Point, Lovett Station, which has since closed, and Tompkins Cove. So you can see this thermal plume that comes off of this release of water back into the Hudson River. And as we mentioned earlier, and I'm sure you're all aware, fish have a specific temperature in which they thrive, in which they are successful. And when you change that temperature on them as they're moving through the system, so they're moving back and forth in the waterway, it has tremendous impacts on them. A lot of them can't adjust their swim bladders in time to really deal with that temperature change, and it would pop them up to the surface and they would die. So really big problems with not just Indian Point, with lots of power plants on the Hudson. They have been put on notice and have been closing down or bringing themselves into compliance. So this is a story that is changing as we are talking, which is great. So we're seeing successful adjustments to the impact of these on the river. Okay, so those were PowerPoints and our real energy need. Now we're going to pop into climate impacts. This is actually not water temperature, this is atmospheric temperature that is showing us that atmospherically it's gone up about 2 degrees C. This is New York statewide, by the way, and adding in the Hudson Valley. This is a Hudson Valley graph, but the New York statewide, it's gone up 2 degrees in the last 30 years. And in the winter, it's more than that, it's 5 degrees C. In the Hudson itself, it's about 2 degrees C. And this is taken from Poughkeepsie, who has been monitoring water temperature since the 1800s. So they have a water intake because they use the water for drinking water. And so we have this reliable data, which is wonderful. Often you don't have these long-term data sources. So you're trying to put things together from intermittent temperature readings. But in this particular case, we have this long-term record that tells us that it's gone up 2 degrees. And of course, our fish have ranges. They use temperature as cues for migration. So this has an impact on the whole system. And this is one of the fish that has really suffered from this change. This is an Atlantic tomcod, also known as a frost fish. They're very cute, aren't they? I just love these little guys. So they're a salty, brackish, cold water fish. They have a little barbel, which is, I think, pretty close to impossible to see in these pictures, but there's a little barbel down here. And they use that at their bottom feeders, so they use that to detect food on the bottom of the Hudson. We are at the southern end of their range, so they tend to like cooler weather than us. They're just kind of hanging out here, but the larger numbers of them are much further north. And they live in the Hudson, but they move up to the northern part of the estuary in the winter. So they're a winter spawner. They lay their eggs in this nice cold water environment. Often they will even lay them under the ice. So they're, again, this is why they're called the frost fish. And you can see that their numbers have gone up and down through history, but you can see that they have definitely taken a dive down since the 1990s. So we can see they're pretty far down here. They're also kind of an interesting fish because they are fairly adaptable. So one of the really cool studies that was done on the tomcod was from the impact of PCBs. So they adapted, the Hudson River group of tomcods actually adapted to the PCBs and were able to filter it out of their system. Whereas if they went to a comparable location where there were PCBs in the system, but not to the large extent that we had them in the Hudson, they did not have that adaptation. So they were able to mutate to deal with that. And I guess it would be an interesting question to wonder if they could also mutate to deal with temperature changes. We would have to see, I guess, but definitely we're seeing their numbers going down.
Okay, and if we're talking about climate change and the water temperature increasing, and we kind of briefly mentioned this earlier, but warmer water temperature does not have the ability to hold the same amount of dissolved oxygen. It holds less dissolved oxygen than cold water. So this is a real challenge for fish. You guys, I'm sure, are familiar. Fish need oxygen to breathe through their gills. And so some of these really sensitive species are being threatened as we're seeing hotter summers, lower dissolved oxygen. And so if you guys are in the Hudson area, I'm sure you have heard about the big fish kills that were happening this summer with the Atlantic menhaden. So I live very close to the Hudson actually, and so I could even see this impact like right in my own backyard. So Atlantic menhaden, they're a very sensitive species of fish. They travel in schools. They're big schooling fish. They travel along the Atlantic. This is another type of winter spawning fish. But a little bit different than the tomcod. So they actually spawn offshore, and then the ocean currents are carrying their young of the year fish into the estuary, where then they spend the first couple of years of their life in the Hudson. So a little bit different. I also just wanted to let Margie talk about this picture because it's an incredible picture that she took.
That was nice. Yeah, so these are amazing, right? I just love this image. This was taken down in Alley Pond Park, and it's a situation where it's a tidal, obviously. The tides move into this little embayment area, and then as the tide goes out, and it brings in massive, there's a little video after this, you'll just see large numbers of these Atlantic menhaden, but they don't manage to get out. As the tide goes out, they get kind of trapped because there's a bowl area that has a little lip over it. And so they're all kind of tight in this one area, and you can see them just going crazy, trying to get enough oxygen to really manage to hold on. So yeah, it's kind of cool, but also kind of
Yeah. It looks like they're literally like gasping for air. Like all their mouths are open. They're like, we need air. So yeah, so very sensitive species. And so as you know, climate's changing, we're seeing increased temperatures in the Hudson. We're expecting our summers to be hotter. Dissolved oxygen is going to be lower during these summer months, and this is an impact that it's more of our sensitive species that really need that dissolved oxygen. If they can't make it out or find oxygen in the more like Atlantic body, then they're gonna have a hard time. So, and then of course not all species have the option like these Atlantic menhaden to go out into the ocean. A lot of our Hudson River species that are more sensitive, they live here. So as dissolved oxygen drops in the summer, they're going to be threatened. Is there?
Oops, sorry.
Oh,
I was just going to pop on the video and then you could maybe answer that.
Amazing.
Oh, I didn't realize there was sound on this.
Oh, I can't really hear it. It's okay. But
Good.
yeah, you can see all these. So Margie, this is the video that you took, right? That they're all just like frantically swimming about.
Yeah.
It's crazy,
right?
So Yanis asks, is there a way to immediately help them if you see struggling school of fish? No, unfortunately there isn't. So this is something that actually it's kind of funny. We were actually just talking about this with our students. There are water bodies that are oxygen challenged, not just in the summer, but year round. And that's mostly due to high nutrient pollution causing eutrophication. And so if you see man-made like fountains or anything that's increasing the water movement, it's trying to increase dissolved oxygen in that area to try and like boost the water quality. That's not something immediate, but that would be something long-term. And that's also very local. Like you couldn't do that throughout the entire Hudson. It would just be in like hot spots where you see dissolved oxygen challenges. So yeah, unfortunately, no immediate solutions for these guys.
Oh, sorry, go ahead.
Oh, he asked, how long does it struggle before they die? I guess it depends. It depends on like what the dissolved oxygen is in the area. Oh gosh, I was like just looking outside my window watching these poor menhaden like struggling, like trying to like shoot up towards the surface, going back and forth. It is heart-wrenching, yeah. Sorry, Margie, did you want to say one more thing about menhaden or DO?
No, I think I'm good. Thank you.
Okay. So I just want to touch on that because that was definitely something that happened in our recent news. So just so you guys are all familiar, it was a challenge of DO. Okay, so our sixth habitat challenge is how do we manage these migratory species that use the Hudson? So these are 5 migratory species, but there are plenty more, and they have different type of migratory strategies. So striped bass, juvenile herring, American shad, Atlantic sturgeon, these guys are what we call anadromous. So they are spawning in the Hudson freshwater, and then as they are growing into their juvenile adulthood, they make their way out to the ocean, where then they live most of their lives until they come back into this freshwater to spawn again. However, our striped bass are kind of a unique story. They found a nice little home in the Hudson as a top predator. So not all of our striped bass are actually leaving. They'll just live their adult lives eating a bunch in the Hudson. So they're funny. And then quite the opposite of anadromous, catadromous, that is our American eel. So this is the only catadromous fish that we have in the Hudson, where they actually spawn out in the open ocean in the Sargasso Sea. Their juveniles, their larvae, they like hitch a ride on the Gulf Stream, where they're shot up the east coast of the United States. They kind of peel off into different rivers and tributaries. Many of them make it to us in the Hudson. They even go past us further north. They live their adult lives in the Hudson until they have reached adulthood, where they once again make their migration back out to the Sargasso Sea, where they spawn and die. So they spawn once in their lives and die after that. So catadromous versus anadromous species. Oh, perfect. So we have these life cycle images to help you visualize it a little bit easier. Oftentimes when people think of an anadromous migratory species, they think of salmon. But for us, we have a lot of species that are local to the Hudson. So our shad, our sturgeon, let's see, as you guys can see the egg here on the far left side in the freshwater, they grow into more of an adult. They migrate out into the marine environment as an adult. And then when it's time for them, once they're sexually mature and they're ready to spawn themselves, come back into that freshwater body to produce their own eggs. So that's anadromous. And catadromous is the opposite. So these eggs on the far right side are now into the marine environment. So out in the ocean, this funny little leaf image is actually a leptocephali. So this is an eel, crazy enough. They have that really long, wide surface area body, so they can kind of catch onto that Gulf Stream and hitch a ride because they are just so small. And then once they enter our freshwater rivers, estuaries, tributaries, they start to gain pigment to kind of camouflage into their estuary turbid environment, and they mostly reside on the bottom of the river, so to match that bottom benthic habitat. So once they start to gain pigment, they're called elvers. There's a middle stage in here called glass eels, where they're completely transparent. If you've ever done any sampling with the DEC, you'll know that they go from the leptocephali to the glass eel to the elver, to the yellow eel, which is their adult stage of life. They're living their lives, let's say, in the Hudson. And then, this is crazy, but the American eels, when they're ready to go out on their journey to spawn, they take the silver eel stage. Their eyes get bigger for their migration. Their fins get bigger. They're like preparing for this journey. They don't eat the entire time. They're migrating back out to the Sargasso Sea to spawn, and then they die. So quite a journey for all of our migratory fish.
Okay, thank you. So we're going to dig into just one migratory species, an anadromous fish, and spend just a little bit of time on it because the American shad is such an iconic species and really brings into play some of the challenges of these migratory species and how they move between so many different areas and so many different habitats. It's really hard to figure out how to help them once they get into crisis. So this is the American shad, and this is an image from 1946 of shad fishermen by the George Washington Bridge. They are the largest member of the herring family, and they are native. So they're native to the Eastern Atlantic seaboard. And they really are an iconic Hudson River fish. They've been fished by the Native Americans before us, then the early settlers, and really by every generation ever since. It was the first fish that was commercially fished on the Hudson and really has been a backbone species since then for us in the fishing industry. And just kind of, to tell you how closely related our history is to that of the American shad. I mean, the American Revolution, the Army was really banking on being able to eat that, and the British actually tried to block the shad from swimming upstream, which I can imagine how that was going. Can you imagine trying to block a fish from swimming upstream? But George Washington helped his troops by feeding them shad during the Civil War. Again, they were capturing the shad fishermen so that they couldn't feed their troops. And during the World Wars, they actually supported the shad fishermen so that they could ship these fish overseas. So they have a tremendously intertwined history with us, which is pretty cool. They have a large range. So you can see from this range map, this very strong kind of orange color is their native range. And so, you know, this brings to mind why it can be so challenging to try and protect their habitat, because they really cover all of these eastern seaboard states in terms of wanting to use the tributaries to go in and spawn and moving offshore. So a tremendous management challenge, right? So again, you know, some of the issues with them is that they use different habitat types during different stages of their lives. So they really need to have this great diversity. There are a lot of agencies that are needed in order to try and protect them, because it's by state, it's multi-state actually. And then there's a ripple effect. So if you interfere with one part of their life cycle, it's going to impact everything else. So you can't just deal with the habitat for one part of their lives. You really need to be thinking holistically about this particular species. So temperature is a really big thing for the shad. And many of you are probably familiar with the shad bush, which was named because it bloomed at the same time that these fish would come through and come into spawn. So, which was in late March. So it's a very early spawner. It comes in when the water's fairly cool. And it moves by the age of 4 or 5, it starts moving north and will go back to its native rivers to spawn. And then they go all the way up to the freshwater section, and they're really looking for the sandy, gravelly bottom, which is challenging because, again, they would have liked some of these wonderful freshwater backwater channels, and also to get into some of the tributaries, but a lot of those got blocked off by dams. So again, we've kind of put a lot of impediments in their area in terms of them being able to actually move into the areas they want. And then just like we heard with the eels using the tides and currents to move their eggs, their leptocephali, here is a similar thing where the eggs are moved downriver by the tides. So it's kind of neat to think about that, just this whole interaction. Nature really is part of every part of this. It's critical for them to be in relationship with their environment. So in New York, we find the shad in the lower, so the estuary part of the Hudson. Of course, they get blocked by the dam here, and then also in the Delaware. So they've been part of our history for many, many years, as I mentioned. And so we're going to just look at what's happened to these fish. So this is in the last 35 years. You can see that much like the tomcod, you can see that they really started to drop way off. The tomcod had happened about 1994. These guys about a decade later, but you can see that their numbers started to fall. And the fisheries were closed in here. So this little teeny spike back up could be because we stopped fishing them. But actually that little spike sadly has not held. So we've continued to see very low numbers, which I think speaks to the fact that we can't base all this on the fact that we're overfishing. There are a lot of other drivers in what's going on in our ecosystem and in their environment. So are we seeing the collapse of an industry, or are we seeing the collapse of a species? And I think that this is a really important thing for us to pay attention to in terms of thinking about our relationship with these habitats and ecosystems. So many things have affected them. So the channelizing, the dredging, changes in the river bottom, as I mentioned, the dams which create obstacles, thermal discharge. Remember, they like a very cold environment. They really come in early in the season to get that cold water. Changes in pH, all of those are problems. And then in terms of egg survival, again, there are a multitude of factors that are really at play here. It has to be the right velocity of the current, the dissolved oxygen levels have to be right, the pH, the temperature, suspended solids again. I mean, there's just so many things to think about, as well as predation. So it's it's a really complex system, and I think that that was the point that we wanted to make with these migratory species, is that they are very challenging to manage. And then just to look at the future, so this is looking at climate change by 2050, using an IPCC scenario, and looking at the fact that their range is going to shrink. So this is going to be just too warm for them, and so they're going to be forced a little bit into a narrower area, which again is going to have an impact. So shad is one migratory fish, but there are a whole lot of others. And so just to kind of walk through this graph, we're looking at species. So this is a 10% line of what the 10% of that historic number of the species is. You can see that the species that's doing the best is the American eel, but it's only at about 30% of its original numbers. And if you go down to shad, alewife, blueback herring, rainbow smelt, since then we just don't even see them anymore in the Hudson. I mean, this is a really big impact that we are having by changes that we are responsible for, and potentially could help with reversing by our relationship with our ecosystem.
Okay, just very quickly, we wanted to end on a success story. So in Manhattan, this was back in the 80s, there was a proposal to create the Westway Highway, which was this huge $2 billion project, but majority of the project was going to be federally funded. So they saw that as a huge positive. It was going to create this huge 6-lane highway along the west side of Manhattan down to the Battery. It was going to create jobs. In theory, people were like, this is a great project. However, this project required a huge expansion of Manhattan and a huge filling of the west side, which would have disrupted this very vulnerable habitat where striped bass use it for overwintering and spawning. And so this project, so right here it says it would kill 64% of the striped bass habitat in this process. So because of the argument of the striped bass as using this critical habitat area, this project was actually abandoned, which is kind of great to know that there were local, so the Hudson River Fishermen's Association, there were other organizations that helped to fight against the creation of the Westway, even though so many people were pushing for it, you know, when it looked at the impacts of the habitat of these native fish, it was abandoned. So kind of a positive. And yeah, so this is, sorry, this is the new one. I didn't see this one. So this is just a little striped bass. So it's kind of funny, like these little guys are the reason to make the difference. So there's an overwintering area and then nursery for this little striped bass. And that, I mean, that's a juvenile, but they get to be quite large. So, yep, that is a full-grown striped bass. And kind of as we mentioned before, you know, they are migratory, but they have found a nice home in the Hudson because there's just so much food, great shelter, great habitat for them. So they've kind of stuck around. And, you know, we might not see the numbers that we have today of striped bass had the Westway Highway been put in. So a nice success story for the striped bass guys. Okay, so I know we don't have a ton of time left, but I did want to kind of give you guys an introduction to the activity. So I think throughout this entire presentation, some key takeaways that even though we, like as humans, we have made some changes to the native habitat and we have live in a very urbanized area, it's still a critical habitat for so many species that still reside here. And that New York and New Jersey has created areas that they have identified as critical habitat areas to try and better protect these habitats for a wide range of species, not just the endangered ones, but tons of species. So this is an example of a assessment criteria of a New York site. You can see that they go through each kind of reason, ecosystem rarity, species vulnerability, etc., and give it a score. The final score at the bottom is the critical habitat score, so how it ranks in comparison to other critical habitats in this area. So I just want to make a quick note. New York has done this quantitative assessment. It's a little bit subjective. New Jersey has not done this quantitative assessment. However, both have recognized critical habitat areas. Okay, so the activity, and we're focusing on Rockland because we're located in Rockland, but we also have this activity for other areas of the river depending on where you guys are and where your students are. So what you are going to do is each one of these critical habitat areas in the Rockland section of the Hudson is identified with a number here. So it goes from 5 to 1. Iona Island, located up here, the farthest north on this map. The Hudson Highlands, number 4, right below it. We have Haverstraw, which is the widest section of the Hudson. So that is located right there in the Hudson River. Hook Mountain is number 2. And then the lowest one on here is Piermont Marsh that we've already talked about. So Iona is identified as being highly valuable because of the species that live there. So it's a bird habitat with 3 threatened species: bald eagle, northern harrier, am I pronouncing that right? And
Harrier.
the harrier, pie-billed grub. Is that right?
Grabe.
I'm obviously not a birder, so my apologies. And I think it's also interesting that they have included human use as being a reason for this habitat being so critical. But, you know, we are a part of the environment. We aren't separated from the natural environment. So that's incorporated in as well. The Hudson Highlands, number 4, this is extremely valuable for the ecosystem rarity. So it's deep, turbulent river channel. So this is a really deep section of the Hudson. There are strong currents with this rocky type substrate. The species that live in this area that are vulnerable are Atlantic sturgeon, short-nosed sturgeon, and bald eagle. Haverstraw Bay, this is that really wide section right there in number 3 in the middle of the Hudson. It's an extensive shallow estuary habitat. So this is rare in the Hudson and throughout New York State. Species that live here, just to name a few: Atlantic sturgeon, short-nosed sturgeon, bald eagle, and the common loon. Hook Mountain, number 2. I'm sure if you guys are from the area, you've been to Hook Mountain before. It is valuable for human use, so it's a valuable site for migratory birds, majority of raptor populations, and hawk watching in New York State. So I know if you do live in the area, you may have been at Hook Mountain before. And finally, Piermont Marsh, we touched on this. This is like our local critical habitat because we're located right just north on Piermont Pier. Ecosystem rarity, it's the only large undeveloped brackish marsh on the Hudson. It's actually the largest saltwater marsh in the Hudson. Species vulnerability, the pie-billed grebe. And least bitter tern. Bitter. Got 'em. And then human use. So there's lots of research and education happening, and birding, of course, in this area. Okay, so that being said, how would you guys rate these different areas from most critical habitat to least? They're all critical habitats, but from the most critical to the least critical. And you guys, if you have been with us yesterday, you can use the view options and annotate. You could also write it in the chat. So you can just kind of annotate numbers here. So view options, I'm just going to pull like a drawing feature. You could put like 1, 2 next to these in terms of 1 being most critical. Or chat, whatever is easiest. John says I'd have to know which were the keystone species. So the species that are highlighted as notable and vulnerable in these areas that use these habitats are the ones listed here.
So there's a much larger activity that you can do. We just want to do something quick with you. I also want to mention that we're pushing up on 1:30 and we probably have 10 minutes of material left. Are you guys okay with sticking with us for 10 more minutes? Hopefully you are, but if you're not, we understand. But we're in the home stretch of just kind of showing you some activities that you can do with your students. So hopefully this will be quick and useful.
Yeah. Okay, so we have someone coming in saying Piermont is the most critical, Hudson Highlands second most, Haverstraw third, fourth Iona Island, and I assume that means Hook Mountain is fifth. Okay, I don't know if anyone else wanted to take a stab at it, but for the sake of time, maybe we'll just share. So again, this is New York Critical Habitats. They have created a quantitative assessment of each one of these sites. And so this is how they ranked it. Haverstraw is actually number 1. So Haverstraw, yay! We love Haverstraw Bay. Haverstraw Bay is amazing. It is, so I caught my tongue before I gave too much away, but it is the widest section of the Hudson. It's also really shallow. It is so critical as a nursery area for fish. It provides a ton of food. It's just north of the turbidity maximum, so that means that the water clarity is pretty low, which actually helps for camouflage and protection for these young of the year fish. So it is just such a great nursery, and it's so critical. And it's also recognized across the entire eastern seaboard as a critical habitat. So yay for Haverstraw Bay. Then we have Hudson Highlands. So I think it's the ecosystem rarity and the use by these vulnerable species as just being so critical. So it's just this really, really deep section of the Hudson. It's got really fast currents moving through it. And of course, Atlantic and short-nosed sturgeon being endangered, Atlantic being that migratory species, but our short-nosed sturgeon being our residents, both using this area makes it pretty important. And the bald eagle, of course. Then we have our Iona Island. So remember, this is one of those Hudson River National Estuary Research Reserve spots. So there's a really important marsh here. Iona Island has a lot of species vulnerability that live in this area as well. Then moving down to Piermont Marsh. We love our Piermont Marsh. It is high in our minds, but it ranks 4th on this list. Ecosystem rarity. It has a lot of species that live there. I think, historic Piermont Marsh looks very different than what it does today. As Margie mentioned, we have a lot of Phragmites, which is an invasive that's changed the marsh, but still a critical habitat nonetheless. And our lowest ranking is Hook Mountain, still important, but it being really focused by human use, I think makes it ranked a little bit lower than some of these others that have species vulnerability and ecosystem rarity. Okay, so now that you know a little bit more, and just to give you guys some more background, we kind of give you the footnotes version. There are more extensive write-ups if your students wanted to break up into groups and each have a site, then they could read it in teams, but that was kind of like the footnotes version. But now that you know a little bit more about each one of these, which picture matches to each critical habitat, just from what you already know?
So maybe to expedite it, maybe if we go down by starting with Iona Island and see if people can identify which picture might match that.
Perfect.
That be okay?
Yeah, that's perfect. Okay, so Iona Island, number 5, farthest north on this map. Which one is Iona Island? Yay!
Good job.
Nice annotation feature, everyone. You are absolutely correct. Iona Island is C. Check marks the spot. That's me. Okay, number 4, Hudson Highlands. Which one is the Hudson Islands? Tricky. Okay. So we have some people saying A. We have some people saying E in the chat, and then some people saying B. Okay, so if you said B, you are correct. Ding, ding, ding. Hudson Highlands. So this is actually an image of Storm King that Margie talked about earlier. So this beautiful, beautiful landscape here. Okay. Number 3, Haverstraw Bay. Which one is Haverstraw Bay? Remember, wide section of the Hudson, pretty shallow, great fish nursery. Yes, I don't know who did that, but E, you are correct. And Hook Mountain. You could probably do this by process of elimination of Yay, Hook Mountain, A, that's great. And Piermont Marsh. Ding, 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 Piermont Marsh. And you can see all that Phragmites in the back, which is that invasive that we had talked about earlier. Great job, everybody. Okay, so if you don't live in the Rockland area and you live more in the New York City area, we have this version of the activity that we can provide for you. These are the write-ups I was talking about that are a little bit more extensive. They have pictures. They also have quantitative numbers associated with them. This map is pretty, like each red dot or line is represented by one of the critical habitats. So your students in theory would break up into groups, have a site, identify where on the map that site is based on the readings, and then they would kind of go into a discussion and or debate to decide which one is the most critical, and then you can kind of unveil the answers at the end. So this is looking at the lower Hudson, and we have a New Jersey specified activity. So New Jersey, remember, did not create numbers for each critical habitat, but you could work on it the same way that each group could have an area, locate it on this map, and then have like a little bit of a debate. And actually, you could even spin this off into another project that Margie is going to talk about right now.
Okay. Well, actually, I'm going to also mention that so there's also an upper Hudson critical habitat list. It's a little more challenging to actually develop a map around, so it would need a series of maps because the upper Hudson, as you may know, is long and skinny. And so trying to actually get enough space around it to look at different areas doesn't work as well. So it would be thematically by certain areas, but there's a tremendous amount of critical habitat, a lot of it relating to the spawning areas that's important up here. So again, we have all those areas pulled apart. I did want to show you a student activity that I've done where we actually, so I had the students select an area from the Hudson sites that are identified by the New York State, and we'll give you we'll give you a PDF of a variety of them that we pulled out, but we'll also give you the link to the New York State critical habitats list so you can play around with it yourself if you'd like to. And what I did was I had them create a PowerPoint, and so in their PowerPoint they had to identify the location and habitat. They had to explain how the state rated them. So what were the things that the state actually thought were important. Then they did a little bit of, you can see the pictures here of what was important, what was living there, and what was the habitat being used by. And then I asked them to talk about the larger role in the ecosystem. So is this an isolated? No habitat is isolated. So having them think beyond that in terms of how else does it fit into the ecosystem, the larger Hudson ecosystem. Then thinking about what might impact the area. So what changes might actually threaten this or cause issues for this particular habitat? And if we lost it, what species might be impacted? So it might be the ones that are already using it extensively and listed, but these species are also related to other species. So having them kind of think beyond this immediate usage and think about how else it might be affected was the intent of that. And then having them think about what's the best step towards its protection. And then if you wanted to even take it further, you could have the students try and defend their particular habitat against others in the class. So why was this important and why should we rate this higher than perhaps another piece? And this, you could do this with any section of the Hudson, but it worked really well. And then we just wanted to end by saying that, again, we're at the field station. We hope to be back there soon. We also work on the Day in the Life of the Hudson River, and that's coming up soon in the immediate future. It will be virtual this year. So if you're interested in participating, please register or let us know, and we'll be happy to get you connected into it. It's a great opportunity for classrooms, students, and teachers, all of the above, to really gain more knowledge about the Hudson. We learn something every year that we participate. So a really important activity. And then we'll drive you to our field station and ask you to explore the resources we have on that website. We'll be adding to them. We'll be adding this particular set of activities. Actually, all the ones that we're doing this week will be archived here as well, so that they'll be in one-stop shop. And we hope to see you there soon. And we wanted to end by going back to our Mentimeter. And I think Laurel's probably putting a link in the chat. I mean, I see her typing busily. Maybe she's not.
I wasn't. I was actually, I can actually just say this out loud because I was typing and I was like, actually, this might be important for everybody. So we have done the activity with teachers at a professional development. In total, I think with your students, it'd probably take an hour if you're breaking them up in teams, giving them time to read, mapping on the map as a group, and then having a debate. That would probably take an hour. However, the PowerPoint before talking about habitats and challenges, we have not done that with students before. I would suggest breaking it up by different topic, maybe over the course of a couple days or a week, and then you could kind of sprinkle in with these activities as well.
And Deborah asked about getting the slides and printouts from today and yesterday. They will be, you'll get a notice from us. There, it takes us a little bit of time to turn them around. Usually we do a kind of a summary sheet to go with them, but you should get it. Nina might be able to answer that, but I think maybe 2 weeks is what the projection is.
Yes, we are working on those and we are hoping to have them out as soon as possible. And if we can get them out sooner than 2 weeks, we will try our best to do that for you.
And Laurel did put the Mentimeter link in so that we could end with this. It's just always, for us, it's really a great way of seeing what you took away from the time we spent together, if there was any change in the way that you're thinking or looking at things. And if everybody's got, you can get that link out of the chat. So I'll stop sharing so Laurel can show the results of the Mentimeter.
Sure. So I'm showing you guys now. It's actually pretty cool because it changes as people are adding their answers. But if you were doing this as a very strict pre-post, you probably wouldn't want to share it because it could probably influence other students' answers if they are able to see what everyone else wrote. But this is amazing because it looks like no one has chosen the same word yet. Okay, diverse. Oh. But that's great. I mean, that's the whole goal of these pre-posts is we would expect that if this is a topic that is more unfamiliar with your students, it wouldn't be as diverse in their answers. Maybe like a couple words were highlighted very large. And after the program is over, you would expect it just to be like way more colorful with so many other words, so many things that they've learned. So I know we have 9 right now, but just to show you what you created at the beginning, this was the beginning of the program or the beginning of the lesson, and this is at the end. So it is so impressive. Yeah, it'd be great to see what your students came up with as well.